Welcome back, guys. We're going to take a look at this little portable mini battery DIY spot welder, $25 straight from China. And I'm sure this isn't the first review that you've watched on this. There's a lot of other reviews out there that's going to straight up tell you, you do not buy it. It's going to blow up. It's a piece of crap. Don't waste your money. Buy it. This is a good little spot welder. Now, this isn't designed for people who's going to be doing like mass production of battery packs. What is a mini spot welder? Well, we use these for the little 18650, 21700 cells to basically spot weld our little nickel strips to it. And we like to spot weld these strips better than soldering, because soldering, you can put a lot of heat in the cell, damage the cell. You can put a little bump down there, so if you got tight tolerances, you don't want buildup of solder on there. So really the best way to connect these cells when you're building a battery pack is a mini spot welder. Now that we got that out of the way, excuse me, this is designed for the hobbyist, the tinkerer, the guy like me who likes to repair battery packs or build small tool battery packs. When some of my old ones wear out, I like to save the case and put newer, higher quality, more amp hour batteries in them, and I use this spot welder to do it. So why are spot welders blowing up? Why are people out there who are engineers, they really look like they know what they're doing because they got electronics all over their desk, like, damn, this guy really knows what he's talking about, so if he blew his up, maybe I'll blow mine up? Well, let's get into that. I think what the problem is they're not following the instructions. I've got the instructions right here. We're going to go over that. The first thing I noticed that everyone who blew one up has in common is they were trying to run it off of a small battery backup battery. Okay, it's a 12-volt battery, but it doesn't have, it can't discharge the amount of current needed to run this welder. So what's happening is, I know there's going to be some electrical engineers out there who says, no, you're dumb, this is not how it works, while you're giving wrong information. But if you don't know what's going on, I'm going to try to help you visualize a little bit what's going on. Okay, so this thing has 5 MOSFETs in there, and that's what people's blowing up the MOSFETs. So imagine that these MOSFETs, they're actually an electronic switch. But let's just, for the sake of conversation, let's pretend that it's this is a mechanical switch. Okay, so what happens if you take a big switch and you got a ton of current going through it, and you try to activate that switch real slowly, you start to see the arcs come across and it starts smoking, like the old mad scientist movies or whatever. But because but till that switch has good hard solid contact, that amperage is going to be shooting through there, and you're going to build up a lot of heat. And that's kind of what happens with these MOSFETs. If you can't provide them the voltage and the current they need, it's like a weak switch. That MOSFET has to close hard to shoot that current through there. And if you don't have a good, solid, hard, closed contact, your MOSFET's going to explode. So what they're doing is they're using these little tiny backup batteries. Like I said, yeah, they're 12 volts. Just like this car battery is, fully charged, it's 12.6 volts. This lawnmower battery right here, fully charged, is 12.6 volts. This model airplane, or matter, using a model car, lithium-ion battery, it's 12.6 volts, fully charged. Well, what's the difference in all of them? So the battery backup that people are exploding this with, they're using tiny little alligator clips, and they're putting it on this thing. And let's just read the instructions real quick. Maybe this will make sense. Okay, so according to actual tests, welding nickel-plated metal strips, these little strips right here, with a thickness of 0.1 to 0.12 millimeter, these strips here that I have are actually 0.1, requires a working current, which means it needs current from a battery from 120 to 180 amps. If the battery cannot output the current in this range, it cannot be, there's some weird Chinese translation going on here, but basically you need a discharge rate of 120 to 180 amps. Okay, those little backup batteries, there's no way they're going to discharge that amount of current. I think where the confusion sets in is that the directions say that you can use one of these model airplane batteries. 4 to 6,000 milliamp is what they're saying to use. You know, in a battery backup, one of those batteries, you know, they're usually like between that, you know, a good one's between like that 7 and 9 amp hour, you know, so that's more than a 4,000, 6,000 milliamp battery like this, right? Because this is 4 to 6 amp hour. Your battery backup can produce 7 to 9, so why wouldn't that work? Well, the problem is, yeah, you've got 12 volts, so these all have 12 volts, right? They all have the same potential of 12 volts. But this has a rating of 50C. So what does that mean? So to figure out the amperage that this can output, we take, you know, 5,200 milliamps, you know, convert that back to amps, which is 5.2 amps times their 50C, and that gives you an output potential of 260 amps. So that is way more than is required to weld that 0.1 to 0.12 millimeter battery strip, right? So this can discharge that current, no problem. Although it's a lower amp hour rating, it can discharge the amount of current this requires. Let's look at our bigger car battery here. It's not a big car battery, but it is bigger than this. So the thing that you're going to find on your car batteries when you're looking at them, you're not going to find an amp hour rating, and that's another thing that this is saying, that we can use a 12 volt car battery from 25 to 40 amp hours. So 25 to 40, when you look at your car battery, it doesn't really give you an amp hour rating. What it's going to give you is a cranking amp and a cold cranking amp rating. That's not to be confused with amp hours. So this one right here, for instance, is a good battery. I've tested it. It's 12.6 volts, and it has cold cranking amp of 400 cold cranking amps. So how do we know? Because there's nothing on here that says what the cranking amps of the battery are. So what we have to do is convert that back to amp hours, and there's really not a great way to convert that back to amp hours. But the rule of thumb is we can take the cold cranking amps divided by 7.25, and that'll kind of get us in the neighborhood of our amp hour rating of the battery. So if we take 400 cold cranking amps divided by 7.25, that gives us 55 amp hour. This says it requires a battery from 25 to 40 amp hour. So that's a little hot according to the instructions. That's a bigger battery than what's required. So they do give us a range, but I know you don't want to be under that, but I'm not sure about going over it because I love using this battery. It makes awesome welds. But if I blow this up, in my mind, I know that I'm outside the specs of my instructions, right? And then let's take a look at the lawnmower. I took this out of my lawnmower, my little riding mower, right? And it is 230 cold cranking amps. So we take 230 divided by 7.25, 8 to 9, so take the 1, that gives us 31 amp hours. So, is that right? Yeah, 31 amp hours. So, 12 volt car battery from 25 to 40 amp hours, 31 amp hours. That one is like in the sweet spot of, you know, according to the instructions, that's right where we need to be. So I would feel good about using the lawnmower battery. I would feel better about using that one than the car battery, but I still like this one. And again, it says for the model airplane battery, 4,000 to 6,000, 45 to 60C, and we just talked about that. You take your amp hours converted to amps, 5.2 times your C rating, and that'll give you the discharge of the battery, so that we know that this battery is more than that, you know, 120 to 180 amps. So all three of these batteries will run this. And you can't use tiny alligator clips. You know, I put these real high end, these are rated for very high amperage alligator clips for the bigger batteries. And one might argue that my cable's too long, but I think I'm supplying the power that I need to this, and I have no issues. I mean, I did extend the cables a little bit, but anyways, let's hook it up. I'm going to hook it up to the larger battery. Be careful when that capacitor charges. When you first hook this up, you will get a little nice little spark out of there. So Real quick, you got 3 buttons on here. You got a manual and an automatic mode. Manual mode, you can run a little foot switch or trigger or whatever you want to use. I don't know why you would want to use that for this little welder. The automatic mode works great. The other switches changes your weld energy. Mine goes from 10 to 90 something, I guess. I haven't even gone all the way up because this thing is extremely powerful. Got a little tiny backlit screen on there. It's hard to see even with the naked eye, so I'm not even gonna try to put it up to the camera. But I've got it set on 20E right now, and I've got my little practice 18650 cell. So 20 is pretty low on the scale, but with this battery, and let me remind you, 20E is not going to work for everybody. It depends on what battery you use. I changed the voltage to get the better weld qualities that I need. So let's just do a couple welds real quick and you'll see how it works. 1, 2, there was 3 spot welds. Now everyone's going to say that your 4th spot welds when it blows up. I've done hundreds of welds with this, but I mean, just perfect, beautiful little spot welds on the end of this battery, and I can't. I usually have to use a pair of pliers or something. Just use my scissors. I don't have my pliers in front of me. See it tearing the metal there? I mean, that's a good solid weld. Still left pieces on there, so the thing does excellent welds. And I just take a file, clean up the end of my battery because it's my practice battery, so I like to put a lot of welds on it. So another thing, if you've never done spot welding with one of these type welders, it's all in the feel. It takes a lot of practice, okay? It's in the feel of it. Will it weld strip to strip? And I'll show you what I mean by feel. So when I first started doing this, I thought you had to push really hard, you know, and have these things perfectly perpendicular. Watch what happens when I have them both straight up and down and I push really hard. Okay? Look, it actually put burn marks on my wood, so it should have went all the way through and make a good weld, right? No weld at all. Let me try it again. I'm going to turn the energy up some. So that was 20E since we're welding strip to strip. Let's just go all the way up to 40 and see what happens. Mind you, 40 is hot. That is very hot, so that should weld that just fine, right? So I'm going to put them both straight up and down. I'm going to push really hard. Woo! I put a really good burn mark on the wood there. And that should be an awesome weld. No weld. So why not? What's going on? When you push that hard, it's the resistance. You know, you have little resistance, and it's not doing the shit. It's kind of hard to explain. The resistance is just going straight probe to probe and not doing the actual weld. So I like to use kind of the corners of it, and you don't push hard. You push just hard enough for the strip to make contact with what you're trying to weld underneath it. So in this case, it's another strip, or if it's the battery underneath it, use the corners and press just hard enough for them to make contact. And it takes a lot of practice. See, I have my weld energy really high and actually blew a hole. I don't know if you can see that, but it actually blew a hole in the strip because it was so hot. But see, that's a proper weld. Just barely touching it, and it welded the strips back together. When I say barely touching it, you know, I had just enough pressure for, and it's a feel, it's practice. You know, I can't tell you exactly how to do it, but if you push too hard, it's not going to weld. You got to have just that right. If you don't push hard enough, you're going to blow a hole in your strip, and you're going to have a really nasty, ugly weld. But that's welded solid. So hopefully that makes sense. And same thing with our battery. I'm going to turn the energy back down. I'm going to turn it down to 15 because 15 does really good on this 0.1 millimeter strip as well. So 15, let's do a few little spot welds here. Okay, just enough pressure to keep that strip. You want the strip to push down to the top of the battery. You don't want to have any space in between it, but if you push too hard, same thing is going to happen just like on that other strip that I just showed you. Okay, can you see those welds? Just beautiful, right? And again, I cannot pull those. I mean, oh, one just pulled off. Yeah, it's starting to rip the strip now, but so that's weld energy at 15. I mean, that's almost as low as it goes, but we got the proper battery to discharge enough current that those MOSFETs close hard and tight and they don't explode. I guess one more representation, you know, just kind of give you a visual of how that works. Let's say we've got your tiny garden hose, right? But that garden hose is hooked up to like a 4-inch ball valve, okay? And then let's say we got that sitting right next to a fire hydrant that also has a 4-inch ball valve hooked to it. Okay, both your hose and the fire hydrant, let's just say they have 100 psi of pressure behind them, okay? And this is just representation. Don't, you know, fire hydrant has a lot more. No, we're just visualizing, okay? So both your tiny hose that's hooked to a 4-inch ball valve, let's just say it's a 1/2-inch hose, and your fire hydrant both have 100 psi of potential pressure. That's like the 12 volts of all these batteries. That's your potential voltage difference in voltage. But for the sake of conversation, they all have 12 volt potential, okay? So now with your little garden hose, let's open up that 4-inch ball valve, okay? What happens? You get a little squirt of water and then it just starts running out the bottom. You've lost all that potential behind it, right? So you open it up, you get a little bit, you get some current out of there, and then your voltage drops, your pressure drops coming out of that valve. Does that make sense? So that's the same thing that's happening with the battery backup these people are using. They got a, you know, 7 or 8 amp hour battery, but it can't discharge the current. So it's like open up that ball valve. You got the same amount of pressure as the fire hydrant, right? Well, what happens when we open up the valve on the fire hydrant that's also got 100 psi? It's going to maintain that 100 psi. It's going to be shooting all the way across the street, right? Where the tiny garden hose just can't do it. So that's the same thing. This battery would be like the fire hydrant. You know, when you open the valve, you ask for that current. It can supply that current and your voltage doesn't drop. And the voltage on those tiny backup batteries, I don't know for sure because I haven't tried one. I don't want to blow this up. But I imagine if you try to pull that much current, you're probably dropping down to like 5, maybe 6 volts, 7 volts. I don't know. I'm just, you know, for sake of conversation, that's what I'm imagining. Which, well, I know that's what's happening, but I don't know the exact numbers of it. And the MOSFETs can't close. That amount of current goes through there. There's a lot of heat, arcing, and it pops your MOSFET. And then you think this thing's a piece of crap. This is not a piece of crap. You just got to read your instructions and do it properly. And for the backyard little tinkerer guy like me, this is perfect. It's small, it's compact, it does excellent welds, everything I've asked it to do. You know, and it's easily to store, you know, and it's cheap, 20 bucks, shipped to the door. And, you know, it came with the welding leads and these short pieces of cable here, and I added these pieces of cable with these high-end alligator clamps there. So hopefully that helps clear some things up, because like I said, if you've seen some of the other videos, you know that, you know, you would think that this is a piece of crap and don't waste your $20 on it, but it's all in how you use it, and make sure you use it right. With that, thank you for watching, and have any questions, please let me know and I'll do my best to answer them. Out.